Okay, vectors. Number 2. What is the resultant force if two ropes are pulling on a crate? One is at 185 newtons and an angle of 130 degrees, while the other is a force of 300 degrees at an angle of negative 30 degrees. We're asked to find the resultant force. That is going to be simple capital F. And we are given some data about the two ropes. One is at 185 newtons. I'm going to call this F1 at an angle of 130. I'm not going to assign a number to that just yet, which you'll understand why in a second. And the second rope is at 300 newtons. I'm going to call this F2, and we also have negative 30. Okay, step 1 is, of course, we need a picture, especially for problems like this. We are working with vectors, so I think an xy coordinate would be pretty nice. Make that right here. And a small tip, write your pictures really big with vectors because it's going to get messy really, really fast. So if this is where, if the origin is, oh, and I should also clarify our directions. The x, this side is going to be positive x. Up, that's positive y. Down, that's going to be negative y. And to the left, we have negative x. It's important to kind of have that in your brain. Okay, sorry, origin, that is where our crate is, and we're going to have our two ropes now. One is at 185 and it's at an angle of 130 degrees right here. This is our 0 degrees. So if I think from here, if this x-axis on the right, the positive x is 0, where do you think 130 is? I know positive y, that's 90, and negative x, that's 180. I don't know, I'm not going to be perfect, but I think it's going to be something like this, where right here, that is going to be 130 degrees. And we have the force of F1, right, which is 185 newtons. And we have the other force. It's going at negative 30 degrees. So if this is 0, or the positive x is 0, we're just going to go down 30 degrees. That is good enough. Right here, I'm going to call this, I know like negatives and are really important, but I'm just going to call this 30 degrees right now. I hope that's okay. And then this is F2, right? Which is 300 newtons. Okay, that's like the first step of drawing our pictures. Now I am going to just think about the problem. We are asked to find plain old F. That F is like, imagine you're actually pulling on a crate with two strings. The crate is going to move in a way. That crate is moving based off of the two forces that you pull it from, right? So that is the resultant force. How do we find that? It's gonna be the accumulation of its x component, the force of the x component, and the force of the y component, all squared. This comes from Pythagoras theorem. I can't say it, sorry. A squared plus b squared. Because we're going to have a force. I have no idea what it's going to look like. It might be right here. It might be like right here. I have no idea. But whatever it is, wherever it's going, if I know the x component and the y component, that makes a triangle. And then I'm going to be able to figure out the hypotenuse, the resultant overall force of the crate. So that is my ultimate equation. That is how I am going to get this answer. So, and I'm kind of skipping my steps right now. This is technically step 2 and 4, but sorry. Now, what is fx? I don't know. I don't know what fx is, because that's going to be, we can only find fx from the sum of the x components of f1 and f2. So I'm going to draw those arrows in red. X component is going to be red. Oh, what just happened? I'm going to have x components in red. So I'm going to look at f1. What is the x component of f1? I just want to look at what's going on horizontally. Horizontally, we start from here, and then we go to here, right? That is our x component of f1. I'm going to call this f. Oh no. Oh no. Hold on. Hold on. We lost our axis. Oh my gosh, it's gone. Sorry. I'm going to call this f1x. Okay? I'm going to look at f2. The x component of f2. It's diagonal. I just want to know how far it goes in the x axis. It goes from here to here. That is going to be our f2x. That is our x components. I'm going to now also label our y components with a different color. Y right here, this is going to be blue. Okay, f1, the y component of f1 starts from here and it goes to here, right? That will be f1y. Now f2, the y component, the vertical component of f2, that's from here to maybe a little more right here, right? I'm going to call this f2y. Now I have made a mistake already. If the right side of x is positive and up of y is positive, then these two, this f1x and f2y, these need to be negative, right? They're going in that negative direction. Okay, so I'm a little bit more closer to finding my resultant force by finding fx and fy, but I'm still not quite there. I'm going to focus on fx now. How should I do it? I'll do it down here. I'm going to try and find fx. How do I find that? That is just the sum of all of the x component forces, right? It's the sum. So we have f2x, and then it's the sum. We're adding, but we have to be careful of the direction. f1x is negative, right? So I'm going to write negative f1x. Okay, still, I don't know what these are. I only know what f1 is, which is 185 degrees, and I know that this is 130 degrees. So now is when we have to think about trigonometry. So as you can see, f1x, that just makes a triangle, right? It's like right here. This is also f1x, or negative f1x. We've got ourselves a nice triangle. This part is 90 degrees. And if we know that this is 130 degrees, we also know from the positive x, from right here to here, that's 90 degrees, right? So if I wanted to find this angle right here, that'd just be 130 minus 90, right? Which would be 40 degrees. I now know this angle we have right here is 40 degrees. Okay, we're trying to find, what are we trying to find? F2, oh, well, oops, I'm looking at F1x. We'll find F1x first then. We're gonna find this one first. How do we find F1x? I need you guys to remember trigonometry. We have F1, which is 185 newtons. We have, oh, disappeared. Sorry. We have the hypotenuse of this triangle, and we have the opposite of this triangle. The trigonomic identity that we want to use for when we have hypotenuse and opposite is sine, right? If that is iffy, you really need to practice these problems because this concept is going to follow you throughout the entirety of physics. So practice this. We're looking for F1x. How should I do this? I'm gonna look for F1x right here in a small box. We know that the sine of 40 degrees equals, it would be like this, right? Adjacent over hypotenuse, would that be correct? And we are looking for F1x. So that means I'm going to multiply both sides by F1, and then our F1x is going to be F1 sine 40 degrees. I am now going to look for F2x. Okay, we need to draw our triangle. We want to find F2x, this red line, right? We also, since F2y, it's hard not being able to point to these lines. This is our F2y, right? We have our triangle, we have the hypotenuse, and we have adjacent, right? That's our adjacent. So, and we also have our angle 30. So when we want to find F2x, we would be using cosine of 30 degrees equals F2. I think of fractions like differently than you guys, so I'm gonna probably make some mistakes. I apologize. We're looking for F2x, yes. I'm gonna multiply both sides by F2, so we'd get F2x equals F2 cosine 30. Now that we know F1x and F2x, I can find the sum of all the x component forces, Fx. So I'm just gonna use these two, right? F2 cosine 30 degrees plus negative F1x would be F1 sine 40 degrees. F2 is 300 newtons, so 300 cosine 30. Do not put anything in the calculator yet. Do not do that. I want to use the calculator as less as much as I can. I don't want to use it a lot. F1 was 185. So it'd be negative 185 sine 40 degrees. And now put that in your calculator. Make sure your calculator is in degrees, not radians. That will mess up your answer. And I think your answer should be 140.8 newtons. Okay, what does that mean? First, it's a positive number. That means that the resultant force is at least going to be in the positive x direction. So that's going to be either in quadrant 1 or, oh man, is this 4 or 3? That's 4, right? Yeah. No. 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 Oh, no, no. This is 3. Oops. Well, one of you know. So it's going to be, and oh no. Oh my God, what is happening? No. No. Okay, there we go. That scared me. Sorry for that. Okay, Fx is 140 newtons. Oh my God. Now we want to find Fy. Fy we want to find. Oh, I should have done this in color. Well, I'll just do it in color now. Fy. Y component is blue, right? Okay. Ultimately, Fy will be found through the sum of the y component forces. So it'd be F1y plus, it's the sum, so it's plus, but F2y is going down in the negative direction. Oops. So it'd be negative F2y. Same as what we did in the x component, I want to look for F1y now. How will we find that? How will we find it, like using trigonometry? F1y. Let's look. Okay, it's this line, right? F1y. We want to know this. We know what the hypotenuse F1 is. So we have the hypotenuse and adjacent. That means we're going to be using cosine. Yep. So F1y, so if we look at our triangle, the cosine of 40 degrees equals BF1. Oh no, oh no. What was it again? Oh my God. F1y, yeah. We are looking for F1y. So we're going to multiply both sides by F1. And F1y is going to be F1 cosine 40. Now we want F2y. F2y is this line right here. Oh, this is bad. F2y. We have hypotenuse, we have opposite. That means we're using sine. Sine of, oh no, sine of 30 degrees equals, it'd be, F2y. Does that look good? Yeah. And we're looking for F. Oh no. Okay. We're looking for F2y. Okay. F2y is F. We multiply both sides by F2, so we get F2 sine 30. Okay. Now that I know F1y and F2y, the y components of each of these forces, I'm going to put that back into our equation. F1y was f1 cosine 40 degrees plus negative f2 sine 30. F1 was 185 newtons. So one, no. 185 cosine, don't put anything in the calculator yet. Negative F2 was 300. I have faith in this pen. 300 sine 30. Put that in your calculator. And it should be negative 8.28, I believe, newtons. So we have our Fx and Fy, our x component of our final force and our y component of our final force. So we want to put that back into this equation, right? I know. Okay, we want to put that back into this equation. Before I put them in, I don't like how f is squared, so I'm just going to get rid of that right now and take the square root of both sides. So it'd be fx squared plus the fy squared. Now I'm going to put my numbers in. Fx was 140.8 squared plus Fy was negative 8.28 squared. Put that in your calculator all at once, and it should be 141 newtons, I believe, something like that. So that is our final resultant force. And we are also asked to find, well, it doesn't say in the question, but the answers also indicated it, so I just think we need to find it anyway. We want to find the angle of this force. So I'm going to actually redraw our coordinate system, this clean one. We have positive y, positive x. So our x force was 140, right? 140 newtons. So we're going like, oh no. I'm definitely pressing a button there. It go erases. So we have that, our fx. And then we have our fy, which was negative, right? So we're going down, but just a little bit. This is all starting for the oranges, but when you're thinking of vectors, you want to go from beginning to end, beginning to end. And now we have our triangle. This is going to be F. And we want to find what this angle is. I'm going to call that theta. We don't know F, that's what we're looking for. We know Fx and we know Fy. That is adjacent and opposite. So using trig, we can say that we can find theta using trig by the equation tangent theta equals, it'd be, oh man, Oliver, oh, I need to finish this before it really dies. Okay, Fy, that was negative 8.28. Oh, oops, sorry, wrong. We want theta. Theta, when we just want theta, we take the inverse of tan. I know, negative 1. Fy was negative 8.28. Fx was 140.8. Put that in your calculator. You should get negative 3.36 degrees. Oh, what is happening? Okay, that is our angle. That is a very, very small angle, which means our triangle most likely, if this is our x-coordinate, that means our triangle probably looks like this. It's a really small angle. But regardless, that's our answer. And I hope this made a little bit of sense. Practice it, solve it 3 times, 5 times, as many times as you need to get this into your brain because you will need it. How do I stop? Oh, okay. Bye.